Hi, and welcome back to Unit 4, Percentages and Managing Merchandise. Today we are going to go through Chapter 7, Section 3. And Chapter 7, Section 3 has to deal with trade discounts in a series. So that's what we're going to be looking at today. Our goals for this particular section. We want you to be able to understand and define series discounts, including the common reasons for series discounts, and we want you to be able to correctly combine those discounts to give you what's known as a single equivalent discount. Using a series of trade discounts, we want you to be able to calculate the net price of your items as well as the amount of any discount. We want you to be able to build a net price factor using the discounts in the series, and we want you to use that net price factor in order to calculate the net price of an item, and then use the net price factor to find what's known as a single equivalent discount and define it. And as it says, find that single equivalent discount from the net price factor. And lastly, we're going to be comparing, where'd that go? Comparing the value of items using that SED or single equivalent discount. So in your textbook, this is section 7.6 and 7.7. Section's not the right word. I think the textbook calls them goals because it's definitely section 3. But I think these are goals 7.8 and 7.6, 7.7, and 7.8. So when we're dealing with chain discounts, also known as discounts in a series, one of the first things we want to talk about are some of the common reasons that you might be given or your business might be given a series of discounts. In our last section, we talked about single discounts, and I gave you 3 main reasons for single discounts. And I cautioned you, maybe, that one of the things that can happen is that you can be given several single discounts. And when that happens, we call it a chain or series discount. The reasons that applied previously also apply here. This would be discounts for positioning in the store. Did you put it on the left or the right? Is it at eye level? Is it on an end cap? Did you purchase in volume? Did they offer you a discount because you bought 250 units versus 25 units? Did you offer to put the merchandise in your advertisement? Or did you offer to display it in, let's say, a shop window? Has your competition been getting a discount? Oftentimes, if you can determine whether or not your competition has been getting a discount, they will give you a discount as well. This is to foster their own sales. For example, if Pepsi is giving Woodman's a discount because they are buying in bulk, they would oftentimes be open to giving Festival or some other grocery store that same discount in order to foster the competition, because when there is competition, we do purchase more. It is a pitfall of capitalism, if you want to say that. Occasionally, there are seasonal items. You may get a discount because you are buying ahead of season. For example, they may be offering a discount currently for Easter candy or for 4th of July for next year. And sometimes you may get a discount if the season has passed. For example, there may currently be discounts on 4th of July material or November 4th Halloween candy, specifically marketed. So, Reese's peanut butter cups that look like pumpkins might suddenly get a discount. All right. What is interesting about our chain or series discounts is that each discount is applied after the previous one has been calculated. This means that the base gets consistently lower. If you've worked in retail before, you may be familiar with what's known as a stacked discount. A stacked discount is when something is 10% off and then it's another 20% off, and they call it 30% off. That's not the case here. In our case, the base gets successfully lower, so each discount has a lesser impact. We'll see how that works in just a second. So one of the things I wanted to show you was how the discount is written. A series or chain discount is written as you see here, 25, 10, 15. 25 refers to an initial 25% off the original price. So whatever the list price was, you would be getting 25% off of that. Then the second number is 10%, and this will give you an additional 10% off of the already discounted price. So it will give you 10% off of the now lowered price. And then thirdly, we have 15% off of the already discounted price. So we took 25% off, and then we took 10% off of that. And now we're going to take 15% off of the remaining discounted price. It's important to note that while this does add up to 50%, your item will not be 50% off. You cannot just add up the percentages. That is not how this works. To show you how it works, we're going to do it 3 different ways. Well, we're not going to do 3. We're going to do 3 different examples so that hopefully you get a feel for how it works. The first example is a calculation of the chain discount the long way round. That is using an algorithm. And an algorithm, for those of you who are unaware, is simply a process that is repeated several times. It is Groundhog Day, if you've ever seen that movie. Maybe you haven't. Sometimes I forget how young you all are. All right, so it's a process that's repeated several times. So what we're going to do is we're literally going to find that discounted percent and convert it to a decimal. We're going to multiply that by our base. To start with, that's going to be our list price. And then we're going to subtract that amount from the base, and that's going to give us what's known as the new base. And we're going to keep returning to that new base and checking off each discount until we no longer have a discount to apply. Here's what that looks like. We're going to have discounts of 30, 20, 15 on $2,000. It's worth noting that this means we're going to get a 30% discount, then a 20% discount, and our last discount will be 15%. So the first 30% discount, we will take our list price of $2,000 and multiply it by 0.3. This gives us $600. This means that our first discount is indeed $600. Now I'm going to subtract that discount from the list price. So I'm going to take the $2,000 and subtract $600. This leaves me with $1,400 left to pay. This $1,400 is our new base. My next discount of 20% will be applied to the $1,400. So we're going to take $1,400 times the 20% discount as a decimal, or 0.2, and that gives us $280. Now I'm going to subtract that $280 from the $1,400. So $1,400 minus the $280 gives me $1,120. This is our new base again. The third discount is 15%, and that's going to come off of this remaining amount to pay. So I've got $1,120 left to pay. So I'm going to find 15% of that. So $1,120 times 0.15 gives me $168. This is my third discount amount, and I need to subtract that discounted amount from the 1,120. $1,120 minus the 168 is $952. This is my new base. However, I don't have a fourth discount. So this new base is the amount that is left to pay. And the remaining money left to pay is $952. Did that seem really long? Because it is. There is a faster way to do this, more efficient. And if you understand it, it works really slick. So here's the faster and more efficient way. We're going to calculate a net price factor. The net price factor, or NPF, is the percent you pay. It does not focus on the discount, but rather it focuses on the net price, or the amount left to pay. In order to build a net price factor for series discounts, you find the complement of each trade discount. In order to find the complement, you subtract it from 100 and then convert that to a decimal, just like we did last section, just like we did with 7.2 and the single trade discounts. Once we know what all of those complements are, we're going to multiply them together. This gives us the net price factor. This is the amount that will be left to pay once all the discounts are taken. But it's that percent, or that portion. It's not going to be a dollar amount. So this is the percent that is left to pay once all of your chain discounts are taken. You can multiply that net price factor by the list price in order to get the amount that is due. So here we have a situation where we have series discounts of 40, 25, and 10 on $58,600. This means that they've been granted a 40% discount, and then a 25% discount, and lastly a 10% discount. In order to determine the net price factor, we need to find the complement of each one of these discount percents. So the complement of 40% is going to be 100 minus 40, which is 60%. 60% as a decimal is 0.6. The second discount is 25%. So I need the complement of 25%, that's 75%, which I will then convert to a decimal of 0.75. Lastly, we have a 10% discount. I'm going to do the complement of 10%, which is 90%, and I'm going to convert that to a decimal as well with 0.9. To calculate the net price factor, I'm simply going to multiply together those three complements. So I'm going to do 0.6 times 0.75 times 0.90. When I multiply these three together, I get 0.405. This means that once all the discounts are taken, there will be 40.5% of the list price left to pay. So 40.5% of the list price remains to be paid. Notice, if I had just added up all the discounts, I would have had 75. 40 plus 25 plus 10 is 75. And if those 75, if they stacked, I would have only had 25% left to pay. But this is not the way series discounts work. They do not stack. I have to find their complements and multiply them together. So in order to find the net price, I'm going to take 58,600 and multiply it by 0.405. That's going to give me 23,733. So I have a net price of 23,733. If I need to know the discount amount, I'm going to take the 58,600 and subtract the net price in order to get the discount amount. We can also find the discount amount if we find what's known as the single equivalent discount. The single equivalent discount, sometimes known as the SED, is a summary discount. It is the total of all of the chain or series discounts in combination. So not a total as in addition, but it's meant to be a one-number summary of all of those discounts in combination. As with everything we did in 7.2, it has to be the complement of the net price factor. So we already know that adding up the discounts doesn't work. So what we actually do is we find the net price factor. We figure out what that is, the same method we used before, and then we subtract that number from 1. We don't convert it to a decimal or to a percent. We leave that net price factor as a decimal, and then we subtract it from 1 to get what's known as the single equivalent discount, or SED. If we multiply the list price by the single equivalent discount, we will get the discounted amount. In order to get the net due, we can take the single equivalent discount and subtract it from the list price, or we can just use our net price factor times the list price again, because it's all connected. Ugh, it can be so confusing, but it's so slick when you get it. So, all right, here we go. All right, we've got a series discount of $25, $15, $12 on $255,000. So the first thing I want to do is calculate the net price factor. So I'm going to find the complement. Oh, wait, let me be clear. The series discount of $25, $15, $12 means we're taking 25% off of the list price. Then we're taking 15% off of the remaining money. Then we're taking 12% off of what remains after we've already taken off 25% and 15%. And no, we cannot add these up. Cannot do it. Don't try. All right. What we're meant to do is find the net price factor. So the complement of 25% is 100 minus the 25, or 75, which as a decimal would be 0.75. Likewise, the complement of 15% is 100 minus 15, or 85. As a decimal, this would be 0.85. And lastly, we'd have the complement of 12%. 100 minus 12 is 0.88. 100 minus 12 is 88. Converted to a decimal, we'd have 0.88. Our net price factor then means we multiply those three complements together, 0.75, 0.85, 0.88. And when I multiply them together, I get a 0.561. This number then means that after all discounts have been taken, 56.1% of the original list price remains. Our single equivalent discount, also known as SED, is found by taking 1 minus the net price factor. The net price factor is our 561. So 1 minus 0.561 gives us 0.439. This is our summary discount. This means that overall 43.9% was taken off of the list price. Our discounted amount then would be the list price of $255,000 times the single equivalent discount of 0.439, giving us a discount amount of $111,945 as our discount. Our net price, we can find two ways. Our net price, we can do $255,000 minus the $111,945 to get $143,055 as our net price. We should also be able to take $255,000 times our net price factor of 0.561. So we can find the net price factor two ways. The first is, or the net price, sorry, two ways. The first is just subtraction of the discount amount, and the second is by using the information we already have, the list price and the net price factor. Okay, there's a lot of information in those three. It was a lot, and I got like 5 examples to go through yet. So here we go. We want to calculate the net price and the discount amount for merchandise that has a list price of $2,486 and trade discounts of $815. Let's make sure we're clear. We have a list price of $2,486. That's our list price before any discounts are taken. And then we have trade discounts of 8/15. This means that our first discount was 8% off. And once we found the new price, then we would be allowed to take another 15% off. So 8% first, then 15%. This trade discount only has 2 and not 3, and that is perfectly fine. All right, so we want to find the net price and the discounted amount. So for both of those, I'm going to do the net price factor. So to do the net price factor, I need to find the complement of 8%. That's 8 minus 100, or 92. And 92 as a decimal would be 0.92. I then have to find the complement of 15%, which is 85, or 0.85 as a decimal. This gives me the net price factor of 0.92 times 0.85. This is 0.782 when I multiplied this through. This net price factor means that 78.2% of the list price is the percent that I'm going to pay. So the list price times that net price factor will give me the net price to pay. So 2,486 times the 0.782 is going to give me $1,944.05. This is my net price. Okay. Now, I can take the list price minus the net price, and that's going to give me the amount of the discount. So I can just do subtraction, 2,486 minus $1,944.05 to get $541.95, and that's going to be my discount. That is a perfectly legitimate way to find the discount amount. Okay? You can also recognize that if you take the list price and you multiply it by the single equivalent discount, you will have the discount amount. Keeping in mind that the single equivalent discount is 1 minus the net price factor, or 1 minus 0.782, which is 0.218. This 0.218 means that 21.8% off is our summary discount, or our single equivalent discount. So I can take the 2,486 and I can multiply that by 0.218 to get $541.95, which gives us a discount of $541.95. This is the same number I got before. There's just 2 different ways to do this problem, and I'm fine with whichever way you prefer. The second way works if you already have the single equivalent discount. And if you've got that single equivalent discount already, then just multiply it by the list price to get exactly the discount. All right. It's more about efficiency than it is right way, wrong way. It's just good to have a lot of tools in your belt. Does that make sense? This is weird. Okay. Here we have a second problem. We have Bookworm buying in volume from its wholesaler, Northwest Publishing. They display Northwest books prominently, and they return very few of them. These practices have earned them a series trade discount of $30.21.6. That means they get 30% off the initial price, 21% off the already lowered price, and 6% off the discount of the discount. If Bookworm purchases books with a list price of $23,000, what is their net price and the amount of the trade discount? So it's like what we did before, right? So in order to find their net price, I'm going to go about it by using the net price factor. So we're going to take the series discount of 30%, 21%, and 6%, and we're going to go ahead and find the complement of each one of those discounts. So the complement of 30% would be 70, or 0.7. The complement of 21% would be 79%, or 0.79. The complement of 6% would be 94%, or 0.94. This means that the net price factor here would be 0.7 times 0.79 times 0.94, or 0.51982. This brings me to a point I haven't made yet. This means that 51.982% of the list price remains to be paid. It's important because it's awkward and you don't want to do it, but we're going to keep every one of those place values. Most of the time when we do net price factors, we keep 5 place values, up to 5. If there's 6, we're going to round it. But if there are 5 places there, we want to keep all 5 of them. All right? Our list price then means we're going to take the $23,000 and multiply it by that net price factor to get our net price. So 23,000 times the 0.51982 is going to give us $11,955.86. This gives us a net price of $11,955.86. The second piece of this is finding the discount amount. So just like we did before, we can do list price minus net price to get our discount amount. So I can do 23,000 minus 11,955.86. That's going to give me 11,44.14. So my discount amount is that $11,044.14. Now, it's not the only way to do this. There is an alternate method. I can take the list price times the single equivalent discount. That should give me the discounted amount. Keep in mind that the single equivalent discount is 1 minus your net price factor. Net price factor, single equivalent discount, have to add up to be 100% of your price. So, single equivalent discount can be found by doing 1 minus 0.51982 or 0.48018. This then tells me that 48.018% was taken off of the original list price. This is my summary discount or the single equivalent discount. If I take the 23,000 and multiply it by that single equivalent discount, I will get $11,044.14, which is exactly what I got with subtraction. And if you really are concerned, you can take that discount of $11,044.14 and add it to the $11,955.86. And when you add them together, you ought to get the $23,000 that is the list price. All right, Something's Fishy, love the name, receives a series of trade discounts of 30/20/12 from Clearview Tank Company. In June, the company had ordered $3,500 worth of merchandise, and in September, they ordered $5,800 worth of merchandise. So here's a situation where knowing a net price factor, particularly if it's consistent, is efficient. So rather than take 30% off each month and then 20% off of that and then 12% of that, rather than doing 3 separate calculations, once they know their net price factor, they can simply multiply that by whatever their monthly bill is. So we're going to find their net price factor by taking the complement of each discount. The complement of the 30% discount would be 70 or 0.7. The complement of the 20% discount would be 80% or 0.8. And the complement of the 12% discount would be 0.88. And now to find the net price factor, we simply multiply those three together. 0.7 times 0.8 times 0.88 to get 0.4928. This means our net price factor is 0.4928. And we've answered the first question. Now that we know this net price factor, we can determine the net price on June's merchandise by simply taking the list price times the net price factor, which is the 3,500 times the 0.4928 to get 1,724.8, which means the cost of the merchandise, or the net price for June, was $1,724.80. What's the net cost then for September's? Well, I don't want to do the 30% off again and then do another calculation that's 20% off and then do a third calculation to take 12% off. I just want to use my net price factor. So I'm going to take the list price for September times the net price factor to get that net price. And that means I have 5,800 times 0.4928 to get $2,858.24. So September's net price is $2,858.24. All right. I've got two more here, this example and one other one. So the Rain Appliance Center purchased an order of dishwashers and ovens listing for $36,000. So that's our list price. The manufacturer offers Rain a series of trade discounts of 23, 17, and 50. So that means 23% off the first go round, 17% off the second subtotal, and 10% off of that. I cannot just add these together, so I have to use my net. Oh, I got to find the single equivalent discount. They asked a different question. So to find the single equivalent discount, that's 1 minus the net price factor. So I need to find my net price factor. The good news is we've practiced that a lot so far. So I'm going to go ahead and find the complement of 23%. That's 77% or 0.77. Then we're going to find the complement of 17%. That's 83% or 0.83. And the complement of 10%, which is 90 or 0.9. To find the net price factor, I need to multiply those guys together, 0.77, 0.83, 0.9, to get 0.57519. This is my net price factor. The single equivalent discount is 1 minus, or the rest of the way, to 100. So I'm going to take 1 minus that net price factor, 1 minus 0.57519, to get 0.42481. So my single equivalent discount is 0.42481. This is the same as saying 42.481% is the summary discount. So even though it says I'm getting 23% off, then 17% off, then 10% off, that is equivalent or the same as taking 42.481% right off the top from the beginning. Get rid of all the middlemen. So what is the amount of the trade discount? Well, the trade discount amount is going to be the list price times that single equivalent discount. So I'm going to take 36,000 and multiply it by the 0.42481 to get $15,293.16. So the trade discount amount is $15,293.16. What is the net price left for Rain? What price are they going to be left to pay? That's what net price means. In order to do that, we can do list price Again, two ways. I know that the list price is the trade discount plus the net. So if I've got the trade discount, I could do list price minus that $15,293.16. That would be fine. That would get me right to the net price. But I could also use the net price factor, and I already have that. I already have the net price factor. So I'm just going to do list price times that net price factor to get my net price. So 36,000 times 0.57519, or $20,706.84. Both of these are perfectly fine ways. Because everything is related, they both work out to the same number, or at least they should. All right, the last example is a comparison of value based on the single equivalent discount. So this example says Marcus Theater buys popcorn from two possible sources. Carnival King has a list price of $21 for 50 pounds, and they've offered Marcus a series discount of 12, 10, and 7. So they're going to give them 12% off the initial price, then 10% off of that, and 7% off of that. Web Restaurants has a list price of $21 for 50 pounds, so the same price, and they offer Marcus a series discount of 25 and 4. In other words, they'll give him 20% right off the go, but then it's like half of what the others were, 5% and 4%. So the question is, who offers the best deal, and can you explain why? So the warning here is we cannot just add up the percents. And in this particular situation, that's misleading anyway, because if I were to add up the 12, the 10, and the 7, that's 29. And then if I were to add up the 20, the 5, and the 4, that's also 29. But there is a difference. One is better than the other. So how do we do that? Well, what we do is we want to look at the single equivalent discount. Because if one of them is giving 40% off and the other one is giving 42% off, I know which one is the better deal. If you look at the single equivalent discount, the larger number is the bigger deal because you're getting a bigger discount. So let's look first at the discount from Carnival King. Carnival King is giving a series discount of 12, 10, and 7. So that's 12% off, then 10% off, then 7% off. And we want to look at the complement of each of those. So for 12%, the complement is 88 or 0.88. For 10%, the complement is 90 or 0.90. Yeah. And then for 7%, the complement is 93 or 0.93. So if I multiply those three together, I get the net price factor, 0.88, 0.90, 0.93, which is 0.73656. I need to find the net price factor to find the single equivalent discount. So 1 minus that net price factor is my single equivalent discount. So if I do 1 minus 0.73656, I get 0.26344. That means the single equivalent discount of Carnival King, looks like the G got lopped off there, is 0.26344. Now, I also want to find that same calculation for Web Restaurant. So if we look at the discounts from Web Restaurant, we see they're offering a 20%, then a 5%, then a 4%. So the complement of 20% is 80 or 0.8. The complement of 5% is 95 or 0.95. The complement of 4% is 96 or 0.96. I'll multiply those three together to determine how much I'm paying. So if we look at the net price factor, it's 0.8, 0.95, 0.96, or 0.7296 when I multiply it all together. This means my single equivalent discount will be 1 minus that net price factor, or 1 minus 0.7296, or 0.2704. This means that the single equivalent discount of Web Restaurant is 0.2706. So looking at 0.26344 and 0.2706, which one of these is the higher discount? If you can't see it as a decimal, try converting them to percents. 0.26344 would be about 26% off of the list price. 0.02706 would be about 27% off of the list price. Based on those two calculations, it appears that web restaurants will offer the best deal. Their single equivalent discount is about 27.6% off. This is slightly more than Carnival King's at 26-ish% off. Since the 27 is a higher discount than 26%, we can say that web restaurants would offer the better deal because it's giving them the bigger discount. Now, you can do this same problem if you look at your net price factor. Net price factor is the percent you have to pay, right? So the net price factor for Carnival King is about 73.6%. So for Carnival King, you end up paying just over 73% of the $21. But for web restaurant, the net price factor, the percent you pay, is just under 73%. Since you pay less, just under 73% with web restaurant, we still get an answer of web restaurant is the better deal, but our reasoning change. Our reasoning changes from because they give a bigger discount to you pay a little bit less overall. All right, 40 minutes in. That's it. Here's our check. These are the things we said we wanted you to be able to do. So can you explain what a series discount is? Can you give some common reasons? And are you clear on how you combine them, that you don't add them? Can you use a series of trade discounts to calculate the net price and to calculate the amount of a discount? We've done that. Do you feel confident that you would be able to do that yourself? Are you able to build a net price factor? Can you use that net price factor to calculate the net price? Can you use the net price factor to find a single equivalent discount? And can you use that single equivalent discount to find a net price factor? Are you able to find discounts using net price factor and single equivalent discount? Can you compare the value of items based on that single equivalent discount? If you feel the need for extra practice for this, there is extra practice in your e-textbook in Chapter 7, Section 3. I believe there are 28 questions at the end of those review exercises. If you happen to have a physical copy of the textbook, you will find this extra practice on pages 207 to 210. There is also a graded assignment with this section. It is creatively called Chapter 7, Section 3, and it can be found on WebAssign. If you have any questions or concerns, please do not hesitate to contact your instructor or possibly the Math support personnel, the Math Center, or any tutors that are available. We are always happy to help.